Welcome everyone to a quick news update. Scrolling by these days here. RISCV high performance programmer here, job offering at Apple, Cupertino there, USA. They're looking for a big picture thinker and anyway, ambitious goals, iOS, macOS, watchOS and stuff, software, hardware. Successful candidate will have excellent understanding, knowledge of RISC-V ISA, with working knowledge of Neon microarchitecture, Neon of course ARM, single instruction multiple data. And so of course it's already in other media. I was already thinking to make a shout out the other day. Now it's already all over the internet, and some news sites of course already color the next transition from ARM to RISC-V, but not so fast of course. So while this is certainly newsworthy or noteworthy, I would expect of course they just had their transition on the Mac anyway from Intel to ARM, so they will not transition another day. Also it probably takes at least 5 years to change all their M1 or M2X silicon from ARM to RISC-V. However, for the future, and yes, certainly they are busy with enough transitions, so not so fast, right? But they could, of course, more easily use this in other microcontroller there, power management, and other wireless stuff, Bluetooth and watch controllers, secure enclaves and stuff. Potentially, in the long term, I don't know, there obviously nobody knows the exact licensing terms there, as Apple needs to license. A lot of people think Apple's silicon is totally their own invention, but no, of course it isn't. That is just ARM, but they do not license the IP block, that is some Cortex whatever from ARM here in the UK, but they probably from the PA Semi, previously power efficient team, have designed something the last decade, or probably since the PA Semi team there from power efficient, for already 15 years. So this is not an ARM licensed IP block, but a whole Apple Silicon own thing, certainly showing with the high performance that is over other ARM offerings from Samsung and other companies. But so RISC-V, probably first in some power management controller and stuff, but certainly Apple, being Apple and one of the wealthiest, richest companies on this planet, having options, right? Even if they don't use it today in an iPhone or tomorrow, certainly whatever comes, there is this NVIDIA taking over ARM, although there is still some legal talks there and government oversight that may or may not approve that. So who knows what is coming with that ARM deal. But yeah, between saving money, potentially being, well, ARM is not that bad, certainly much more risk and reduced than Intel. Although I would say for the most part RISC-V is still yet a little bit cleaner. So I don't think there is so much power and performance to be gained from RISC-V over ARM, maybe 1% or 5%. But yeah, options and also other stuff. So a lot of people always think RISC-V is only in some Sci-Fi, Hi-Fi or other microcontrollers, but even NVIDIA has already probably some power and other management controller here in RISC-V. Just didn't find his best source. I have some Medium article. So this was already some years ago. Was it 2000 or was it even controller? So that was just like whatever, something Qualcomm, NVIDIA. So as publicly visible among Google, IBM, Qualcomm, NVIDIA is a member of the RISC-V Foundation, has long supported RISC-V development, and so 2016 unveiled plans to replace their internal, so similar to that, maybe thinking of all the other additional not high performance cores in Apple Silicon, some internal microcontroller potentially in their graphic card there at NVIDIA next gen. So they are previously probably ARM, if not ARC, or who knows what, often ARM of course, there for controlling frequencies and power management and fan controllers and all this fun stuff. And introduced 2005 Falcon Fast Logic Controllers, a class of general purpose embedded microcontrollers for NVIDIA GPUs, just the surrounding management tasks, ranging from video decoding and memory copying to security. Okay, this is a little bit more than fan controller. Anyway, so yeah, even NVIDIA is obviously doing that for all those people who always think RISC-V is just some open source business. But it will be interesting to see. I also wanted to point out one thing, maybe I should make actually a dedicated video. I wanted to say all the companies, all the non-Apple companies really need to get their act together with that, with all the other, I mean, Samsung, Qualcomm, Microsoft, Google, Amazon, they all have, well, some advertise they have their own optimized ARM cores, but I find this rather misleading, like Microsoft, and who else was that? Probably Google. So yeah, Microsoft and Google with their Tensor or so cores for AI. Microsoft, at Microsoft with the Microsoft Surface ARM-based SKU. They also say work together with Qualcomm optimization there on their keynote and stuff. I find this rather overblown because this is just like a GPU core or something. It's not like it takes so much work, 100 millions of dollar to change the CPU, right? It's not like Microsoft is going to Qualcomm for, what was it, the S1 or S2 or whatever they called that, and it's like, hey, make this like 50% faster. I mean, obviously Qualcomm is doing the best they can to make their CPUs the fastest they can possibly do in their design criteria, research dollars spent and manufacturing die size and so on. So it's not like Microsoft can like just order there's something faster. So it's not just like some GPU core more or whatever, tiny little things that cost like less than hundreds of millions. And in Google's case, also only the Tensor cores. And I wanted to say this companies need to work, get their act together. They actually need to freaking work together, as seen in the performance from the Apple Silicon. Apple, as much as I have a love and nowadays more hashtag PeakBugs hate relationship with Apple stuff, giving credit where credit is due, their M1 and soon M1X and M2 Silicon is, I said this previously, IPC instruction per clock on par approximately with AMD Ryzen Zen 3 and only with Intel's latest Alder Lake. Probably wanted to make a dedicated video about this stuff too. Intel only now is catching up with Zen 3 and Apple's M1. And if the industry, I mean not even to the ARM offerings like Samsung and Qualcomm, that is certainly a huge factor away. And these companies need to get their act together, right? It's like Microsoft having their S1, S2 custom, not really that much custom, Google, and so on. This Qualcomm CPUs are not really competitive with what Apple has there. And these companies, instead of their own pseudo-optimized, not really optimized, not pseudo-custom SKU, it's not cutting it, right? Microsoft, Google, Samsung, Qualcomm, they need to ARM, they all need to get their act together if they want to be competitive, because right now Apple, I would say, with the M1 is, or was, last year was maybe 4-5 years ahead of performance and energy efficiency. And if this doesn't scale, right? If all the companies, all they do is like some Tensor core, some GPU core more, that is not cutting it, right? If they want to stay competitive for the next decade to come, all those vendors, they need to get their act together and freaking work together, right? Because otherwise Apple will just accelerate ahead there. even in Intel, right? I mean, obviously AMD with the EPYC and Threadripping Zen cores, everyone's certainly aware that they currently are the performance leader there, and only Intel, with all their delayed process nodes, is only catching up with Zen 3. Of course, Intel portrays this as the new performance leader. This has to be seen. I expect this to be, sure, maybe it's a little bit faster than Zen 3, but Zen 3 is in the meantime a year old, right? Soon Zen 4. I expect with the next generation also AMD Zen, next generation Zen to be faster than Intel, or even if it's similar speed, whatever. But as said previously, of course, Apple's M1 and soon M2 a much more, nearly Ryzen Zen 3 performance with like a tenth of the energy consumption, or a tenth or a fifth. And if you look at this with RISC versus CISC, what Intel just presented here at the Intel Architecture Days, look at this. Maybe I should not, whatever. This amount of execution ports, right? When people ask me why is the RISC-V unmatched, Sci-5, Hi-5 unmatched board just atom performance, right? Look at this amount of execution ports, right? These are 17, a crazy amount, and previously Intel previous generation was 4 byte issue, meaning decoding up to 4 instructions per clock. I think Apple M1 was 6 byte issue, as far as I remember, and Intel only catched up, right? So this is not even comparing highly efficient mobile grade silicon, but latest and greatest Intel. So Intel is only catching up with Apple's M1 in these numbers. And also look at this, so the current Hi-5, Sci-5 unmatched, that was, I think, dual issue, inline, not out of order. And so yeah, 6 wide and 17 freaking execution ports, right? So for various integer, probably still knowing CISC, dedicated address generation units, and a floating point and vector. Here's vector float, like memory, load store. So this is probably, not sure if they, it's integer register. So this is like 5 floating point vector ports, meaning those parts of the CPU that perform this binary computation there in logic gates, and computing what the software asks the processor to do. And yes, so this is a crazy amount, right? So this is for the what do they call this, golden, so 17, where was this? I had this here. It was a nice summary somewhere. 17, so this is a high efficiency. Wait a second, why is this? Where's the high performance? Or was it high performance not? Oh, this is confusing. I think this is, actually I'm not sure if this is correct. I would expect, so because they have here, so much to using Wikipedia live on your newscast. So new 6 byte instruction decoder up from 4. They said this a little bit strange. In the architecture days, Intel said dual, so like dual 3 wide as far as I remember. So this makes me a little bit skeptical that this might not be a really true 6 wide instruction decoder, but maybe they have this set up like 2 3 wide instruction encoder, as they say, dual 3 wide, so that only certain, like decoding up to 32 bytes per cycle, up from 16, I hope that is correct. And so maybe they have wired the inputs of 16 bytes. So maybe this is kind of the recycled previous 16 byte 3 wide instruction decoder, but just 2 of them, so that depending on the arrangement of instruction, it can issue up to 6, but only a rare limited kind of That's the drawback, recurring theme here, drawback of variable length complex instruction set architecture. Because also this is highly false, misleading advertisement, because they this fetching up to 32 bytes already says it can only issue 6 write instructions if the variable length instruction input has 6 instructions in the 32 bytes, because variable length x86 instructions are up to 15 or 16 byte with all the vector, vex and prefixes and variable length encoding. So if there are 2 very long instructions, there might only be 2 very long 15 or 16 byte instructions in the 32 bytes. So then it can obviously only decode and issue 2 or 3. So yeah, just wanted to point this out. Leave me in the comments below if you want to have a detailed run down of Intel's latest Alder Lake architecture. Only wanted to mention this briefly, that even Intel, the previous leader most of the time in the last decades of high performance desktop, server, workstation, CPUs, is in the meantime at a level that Apple matches with their M1, M1X, M2, certainly next generations of processors. And this is just the amount of what the industry needs to get their act together, especially in the ARM land, certainly Intel, but Intel and AMD both, sure, performance similar. Again, it's crazy, right, that we even talk about latest enthusiast parts per core, per thread performance similar to Apple's mobile part. This is how far ARM has come, and as I said, the industry needs to find ways to cooperate, work together, otherwise they don't stand a chance against Apple's innovation there. And if you ask me why Apple can do this, this is certainly the integration, right? First of all, probably no bullshit business. I mean, first of all, ARM is much more RISC than CISC, much lean and clean and easier to work with architecture. And then certainly having good talent and like not implementing like at Intel AVX 512 or other stuff that AMD did not implement, and even previous videos Linus Torvalds hope dies a quick death because it's simply so much silicon waste, limiting your clocks, as you see if you use AVX to AVX 512, less boost frequencies and stuff. Just so much transistors wasted of usually not used if you're not running specialized, optimized single instruction multiple data AVX 512 or AVX2 code, and where ARM with a new scalable vector extension and RISC-V with the upcoming vector extension has a much better performance and energy balance and scalability, like natural hardware scalability. And yeah, so no bullshit and like not implementing crazy stuff that nobody's using and just looks good in benchmarks on paper, and working with a sane or saner RISC architecture and just implementing what they need. I also heard they implemented stuff specifically for this type of object-oriented code. They are compiling or other ABI details on Apple's macOS GNU application binary interface. And this is, of course, this level of integration, right? When people like probably the LLVM team of previously Chris Ladner at Apple and so on, like real leaders in compiler research, and having all those people in-house talking to each other saying, hey, we need processors that optimize this kind of instruction flow better, and so on. This kind of integration, and not this custom silicon of Microsoft adding a GPU core there to the S1 and Google some tensor cores. And yeah, basically everything, right? Also AI, Apple can just do what they need and have drivers and it just works with all the SDKs and applications, and at Android, Windows, Linux, everything fragmented, incompatible, and yeah, companies freaking need to work together and not make their funny ARM custom SKUs that have no value whatsoever. Otherwise, if the ARM companies continue at that slow innovation speed, Apple will soon be not only 4 or 5 but 8 or 10 years ahead in terms of silicon design and innovation. Anyway, yeah, interesting stuff. I didn't expect Apple to adopt RISC-V that fast. That's unexpectedly faster. But again, welcome to see, because I personally find RISC-V cleaner and leaner and more RISC than ARM. Anyway, Christian Kunz writes, feels weird to say that Apple's pushing the architecture game these days. Yeah, totally agree. This feels really strange. And also with RISC-V, right? The companies, certainly Sci5 is just one startup. And you see how long it takes for a small startup. I said this before. Of course, the current is a dual issue in order. The next is the triple. I'm not even sure if they are at quad issue. But anyway, 3 or 4 issue and out of order. And vector extension, but even that is, of course, Intel performance from probably 7 years ago or something, and it just takes resources, right, to implement that many execution ports. So what would it take to have such a high-performance RISC-V core? Well, get away with all your decoding front ends, slap in here a RISC-V decoder. Should be way easier to do this, like 8 wide or even 10 wide or something, with a much more regular, not variable length instruction set, and just reuse all this. Of course, you can't directly reuse it one-to-one, but hopefully 90%ish. And yeah, so this kind of 17 execution ports and surrounding caches and bus bandwidth and stuff is needed, what it takes to have such a high performance RISC-V core. So yeah, as I said, I don't expect the next transition to RISC-V anytime soon. Visible, again, controller, microcontroller, AI stuff, audio, video, like background tasks of speech recognition and stuff. But yeah, certainly there is an option for that. Maybe in a decade or so, the next transition might be for application processors from ARM to RISC-V. Interesting future to come. Let's see what else do we have there in the comments. Possible they will abandon ARM in the future, go RISC-V. NVIDIA go through. Yeah, as I said, I don't think the next years, but 5+ years could happen. Again, I think Apple has shares, right? So Apple ARM shares. So I mean, ironically, they pay the licensing fees they pay. They probably partially get back. Where is even the, at that point, once 20%. Is it the sole owner? Yeah, who knows? Random answers on the internet may or may not be true. Anyway, once upon the time they had shares or whatever. Iker says Intel was also looking for RISC-V. Yeah, of course, Intel does not transition. I said this before. Maybe for some management cores or just to have some options. Certainly, Intel is very much aware. The last decades, Intel was making so much money because everyone was locked into the x86 with the Windows Intel cartel there, and this would be the death of Intel to adopt x86. Intel will be the last to adopt RISC-V in high-performance application processors, is my prediction. They might use it for the management engine or other surrounding audio, video stuff, controller stuff. But as long as possible, Intel will keep x86 alive just to be the sole kind of sorter with AMD market leader there. Otherwise, if they would adopt RISC-V, well, although there is no other high-performance RISC-V right now, but anyway, why should Intel promote and foster an open architecture when they can lock out competitors with their proprietary x86 architecture? So, old school 978 writes, NVIDIA winning ARM would spell doom for the architecture. I'm not that sure. I mean, NVIDIA also wants some money back, right? So why should they stop competitors if they can cash in there some money? But crazy stuff could always happen. So, but in where do we old school writes, ARM64 is great, RISC-V needs revision, but it's an open either. A lot could be done there. I said I have a previous video, ARM instruction set architecture. ARM previously was not as clean and RISC, reduced instruction set. ARM64 is a huge cleanup. They mostly did away, well, they doubled the general purpose registers and mostly did away with explicit execution predicates on most instructions that were mostly not used. And so yeah, ARM64 is highly incompatible to 32-bit ARM, but welcome cleanup. ARM, again, 32-bit ARM was not as nice an architecture due to those details, previous video, and the variety of legacy floating point implementations and even single instruction as AMD implementations. ARM64 is much nicer, but RISC-V is obviously new and clean from the grounds up, modern and so on. YouTube something, right? That's why Apple GPU performance per watt is almost 2 times higher than their closest competitor. They spend all of their transistor budget on the thing, deliver real world performance for the average customer instead of leaving off focus things like server cloud applications, because Apple doesn't have to worry about being able to. Yeah. I also wonder, anyway, this is probably that. I also wonder about some other things that we better discuss in some future video to optimize viewership and retention and stuff. So I hope you found this interesting. Change is coming. The next decades, years and decades will still be interesting. Don't forget to like and subscribe to follow all this crazy stuff here live with low-level code on this channel.